Here's number 25 from section 4.3. A particle's moving along the x-axis with position function x of t. We're asked to A, find the velocity, B, find the acceleration, and C, describe the motion of the particle for time greater than or equal to 0. So we're going to look at 25 first. There's our position function x of t is equal to t squared minus 4t plus 3. The first thing we can do is part A, find the velocity function. So the velocity we know to be the first derivative of position. That makes this pretty easy. We've got 2t minus 4. So there's our velocity function, and part A is done. Part B, we're asked for the acceleration. So we know the acceleration to be the first derivative of velocity or second derivative of position. And here we have just 2. The derivative of 2t minus 4 is 2. Let's move on to part C, where we're asked to talk about the motion of the particle. So we understand that if the velocity is positive, v greater than 0, then our particle is moving right. And if the other thing is true, if v is less than 0, so we've got a negative velocity, then our particle is moving left. We can also talk about whether the particle is slowing down or speeding up. If we have v positive and a positive, or if we have v negative and a negative, then our particle is speeding up. So as long as the velocity and acceleration are the same sign, then the particle is speeding up. If velocity and acceleration are different signs, in other words, if velocity is negative and acceleration is positive, or if velocity is positive and acceleration is negative, then our particle is slowing down. So keeping this in mind, we probably want to create a sign chart for velocity and acceleration. So let's take a look first at the velocity function, see if there's any critical numbers there where the sign might change. We're going to let 2t minus 4 be equal to 0, and we can quickly see that we have a critical number at t equals 2. For the acceleration, that function is just a constant, and 2 is never equal to 0, so there are no second derivative criticals there. So here's our sign chart. We're going to create a number line. This number line is going to start at 0. It's going to go toward infinity because we assume this particle never stops moving. We're going to partition this number line at t equals 2, and we're going to test the velocity and we're going to test the acceleration. So a nice test value between 0 and 2 is going to be a 1. So let's plug 1 into the velocity function. That's our 2t minus 4. When 1 goes in, we end up with 2 minus 4, which is negative. The acceleration, on the other hand, is, like we said earlier, just 2 all the time. That's a positive number. A of any number is going to be 2. Then let's pick a test value on the right of 2, say, for instance, 3. We'll plug that into the velocity. 2 times 3 is 6. 6 minus 4 is 2. That's positive. And then the acceleration we know is still positive. So it looks to me like from 0 to 2, we're moving left and we're slowing down because we have opposite signs on our acceleration and velocity. Looks to me like from 2 to infinity, we are moving right and we're speeding up. So that's the answer we want to give. We can do that a little bit more formally. We can say something like this. On the interval, well, interval has an O, 0 to 2, the particle is moving left and slowing down. On the interval 2 to infinity, the particle is moving right and speeding up. Now, why is it that I did not include 2 in either interval? I went with the parenthesis around 2, both at the end of the first interval and at the beginning of the second. It's because at time equals 2, our particle is technically at rest. Remember, velocity of 2 here would be 2 times 2 minus 4, which would be 0. The particle's at rest there. It's not moving forward or backward. It's that moment in time where we're switching from a left movement to a right movement, and that's number 25 from section 4.3.